Hi everyone, I am Senranda GDIU under registration number EG20204207, and today I am going to walk you through my Kafka based order streaming mini project for our big data assignment. The aim of this project was to simulate real-time order ingestion, processing and error handling. Kafka works as the central messaging pipeline here, enabling continuous data flow while keeping the producer and consumer completely decoupled. In this demo, I will show how the producer, consumer, and dead letter queue work together along with real-time statistics and retry logic in action. This is the high-level architecture. With the docker compose.yaml file, I spin up Zookeeper and Kafka broker and the schema registry. Here is how the system works. The producer sends error encoded orders to the orders topic. The consumer reads those orders, performs rolling 60-second analytics and applies retry logic. Any message that still fails after 3 retries is sent to the dead letter queue, the orders DLQ topic. The lightweight DLQ consumer listens to that topic and prints the failed messages. So the data flow is producer, orders topic, consumer, DLQ for unrecoverable failures. All order events use this array schema, which includes simple fields such as order ID, product, and price. Using array along with the schema registry ensures a strict data contract, so both the producer and consumer know exactly what fields and types will appear. In producer.py, the schema is loaded and the array producer takes care of encoding each message. Here is the producer script. At the top, I define the Kafka and schema registry configurations. The produce orders function selects random products and prices, and in the main loop, one new order is sent every second with a unique ID. When the producer runs, you will see logs like produced order, indicating the messages are being published successfully. Here is the consumer script. This is where most of the processing happens. A price aggregator using a DQ keeps only the last 60 seconds of data. Every 5 seconds, the consumer outputs statistics such as count, average price, minimum and maximum. The simulate processing failure function randomly fails about 10% of messages to mimic real-world issues. The handle message with retry function attempts to process each message up to 3 times with exponential backoff. After all retries fail, the message is wrapped in JSON and sent to the orders DLQ topic. Successful messages are added to the rolling stats. The consumer commits its offsets, so processed messages are not reread. This script is intentionally simple. It listens to the orders DLQ topic, decodes each failed messages and prints a clean summary containing the order ID, the product, the price and the reason for failure. During the demo, you will see a few messages show up here confirming that the retry and DLQ workflow is functioning correctly. So I am going to demonstrate the project. First, I run the docker compose file. Then I can run the consumer script. Then I can run the producer file. Finally, I run the DLQ consumer file. You will see the producer streaming orders, the consumer printing rolling stats, and occasional retries followed by DLQ messages when needed. This setup demonstrates the fundamentals of real-time data pipelines, continuous ingestion, live analytics, retries and resilience, transparent handling of failures. Thanks for watching.